All right, we're going to look at linear inequalities and compound inequalities, and then one application. All right, in this first one, we've got all kinds of fractions, so I'm going to go ahead and clear fractions. And the way I do that is to multiply everything by the common denominator, which is 12. Okay, so 12 times 1/4, that would be 3x, and then 12 times 2/3, that would be 24/3, which is 8. Times x plus 3, and that's greater than or equal to 12x minus 6. And then we'll distribute our 8. Alright, so I would get 8x here plus my 3x, so I'd have 11x, and then 8 times 3 would be 24, and that's greater than or equal to 12x minus 6. And now I could go either way. I could get x's on the left or right. I'm going to go ahead and just get x's all over onto the left. That's generally easier for me to do. So I've got negative 1x plus 24 is greater than or equal to negative 6. And subtracting 24 from both sides, I get negative 1x. Oops, there's x is greater than or equal to negative 30. And then I do need to divide by a negative 1. And when I divide or multiply by a negative, that's when you have to change the direction of your inequality, giving us that x is less than or equal to 30. And then the set builder for this, that would be the set of all x such that x is less than or equal to 30. And then if we were going to graph that, we would have at 30, we can have anything less than that and including that. So it would be all of these numbers. The shade is representing all of the x values that would make this original equation true. And it's any number less than or equal to 30. And then you could also draw that as a closed circle. Okay, and then the number line goes from negative infinity to 0 and then over to positive infinity. And with interval notation, we're basically just taking a little picture of the endpoints of the graph. Okay, and so since this is all numbers getting smaller and smaller without end, we would just say that they're going towards negative infinity. And we use a parentheses there because you give me infinity and I'll give you infinity minus 1. So there really isn't a place that I can go stand on and say this is infinity. We just have to have a parentheses. And then that bracket says we get to include our 30 as a part of our solution. All right, let's try another one. We've got another equation or inequality with fractions. So go ahead and do that first step of clearing fractions. You can pause the video. All right, so we multiply everything by the common denominator, and then we're going to simplify. I'll give you a minute to do that. Go ahead and pause. All right, so now we have, when we try and get all of our x's on one side of the equation, they end up canceling out, and we've got 0 is greater than 1. And that is a contradiction. So that means that this equation, this original equation, has no solution. And then you can either say there's no solution like that, or you could say it's an empty set. And that is done. So the next thing we're going to look at is compound inequalities. And so basically that means it's two inequalities that happen at the same time. So we've got for our inequalities 7 is less than 3/5 x plus 1 and 3/5 x plus 1 is less than or equal to 8. So we can go ahead and solve those separately. I'll also show you how to solve them, put them, solve it simultaneously. Some people like to do that. All right, so separating these, we would get 6 is less than 3/5 x, and then I'm going to multiply by the reciprocal here on both sides. Okay, so on the right side I would get 5 times 6 is 30, divided by 3 is 10, so 10 is less than x. And now we can solve this other one, so we would get 3/5 x is less than or equal to 7, and multiplying by the reciprocal on both sides would give me x is less than or equal to 35 thirds. Okay, and for me to put these together, then I personally like to graph them. So I've got a 10 and then 35 thirds. And that's a little bit less than 12, so we would have all these numbers in between there. Okay, and so then our interval notation would be going from 10 but not including it, so that's when we have our parentheses, up to 35 thirds and including it. So there's our interval. And then our set builder, we would have the set of all x such that we go between 10 is less than x, which is less than or equal to 35 thirds. Okay, good. And the goal is to have the x in between two values. So let me just show you, there is another way. Some students like to just put this together as just one big problem and not separate it, so I can show you that too. It's really preference, whichever you prefer. Okay, so we could solve these both at the same time. You see how right here I subtracted one from both sides? I can go ahead and just do that all together and kind of do, you know, everything. So we get 6 is less than or equal to 3/5 x, which is less than or equal to 7. And now I can multiply by the reciprocal on everything. And so then I get 10 is less than x, which is less than or equal to 35 thirds, and that's done. All right, perfect. All right, we'll try another one, and it's up to you whether you decide to solve these simultaneously or separate them into two different inequalities. I'll show it both ways. All right, so go ahead and get started. Write down what you think the next line would be. You can pause the video. All right, so if you're separating these, you would take one inequality and then your other inequality would be this one right here. Okay, so we'd separate those, and now we're going to get the y's on one side, the numbers on the other, and I'll go ahead and let you pause. Okay, so I'm going to just move my numbers over. So I've got -4 is less than -4y. And then I'm going to divide by -4. When I divide by a negative, I need to flip the direction. So I've got 1 is greater than y. And then this, we can look at that. If I put my eyeball over here and I'm looking at it, you see how I'm reading it as y is less than. You can kind of read these with a point system. If I'm reading it this direction, I've got y only has 1 point, whereas the 1 had these 2. So y is less than the 1. Okay, and then over here, I'm subtracting 1 from both sides, and I've got -4y is less than or equal to -2. Dividing by a negative, we need to flip, change the direction there, so I've got y is greater than 1/2. Okay, and I'm also showing if you had solved this simultaneously. All right, so if we just solved it all together as one inequality. Okay, good. And so now, if we had done this all as one inequality, this wouldn't be correct. This couldn't be my set builder notation because the inequalities are going the wrong direction. So I would need to clean that up. Let me show that from this side. And so let's see, we take the smaller number. Our number line goes from left to right, smaller to larger. So I need to put my numbers going from left to right. I have here the y is everything less than 1, but not including it. And then here y can be equal to or greater than 1/2. So we put those in order, and then our interval notation includes 1/2, goes up to 1 but doesn't include it. And then here's our set builder, the set of all x such that we go 1/2 is less than or equal to x, which is less than 1. Oh, and those are y's. Whoops. There we go. Good. All right, so here we would just need to put this in order with the smaller number furthest to the left. So 1/2 is less than, it only gets 1 point, whereas the y's got 2 points. So 1/2 is less than y, and then y is less than 1. So there's our set builder, the set of all y's such that y is going between 1/2 and 1. And that's done. Okay, looking at where a inequality might show up is an example when we're trying to compare two rates. So let's say that one cell phone company charges a flat rate of $35 a month, and then they charge you for every text you send, and then another company just charges you $50 with unlimited texting. Boy, that would be nice. So let's see, we're looking to find out how many texts would we need to send for the first company to charge you more than the second. So we want the first company is going to be more than the second company. And let's let x equal the number of texts. Okay, so that first company, it has $35 that you pay, and then for every text, it's 1 cent. All right, and then the other company is just a flat rate of 50. So there's an inequality I can solve. Subtracting 35 from both sides, we would get 1/100th x is greater than 15, and then you divide through by 1/100th, and you get x is greater than 1,500. And now the final step is to write this out as a sentence. So alright, so the first company would be worse. It would be a worse deal. It would be more expensive if you send more than 1,500 texts in a month.